Hello, everybody. Today we'll continue the RTL. Okay, NOR and NAND gates are functionally complete set. Means from NOR, only NOR gate, you can build everything. From NOR, we can construct inverter. We can construct OR. We can construct NAND. We can construct AND. The same for NAND. So from NAND, we can do all basics logic gates. And from NOR, we can do also. So NOR and NAND are called functionally complete set. Okay? So let's begin by two input RTL NOR gate. This is NOR gate. So we put two BGT transistor, collector base emitter, the same of inverter. Okay, we put on emitter the grounded, no resistor here, grounded. From the C, common C here, common collector, two transistors are parallel, common collector with the resistor on 5 volt. The output is from the collector. Here the output. So we have two inputs here, A and B. For transistor 1, A. For transistor 2, input B. So let's make the tracing. For A equal to 0 and B equal to 0, what happened? For 0 this transistor, 0 this transistor, two transistors are off. Okay, so because two transistors are off, so Vout is directly connected to the VCC, and the resistor act like a wire because no current inside it. So the output equal totally 5 volt. Logic 1 equal 5 volt equal V output high. When we have A equal to 0 and B equal to 1, so A equal to 0, this transistor is open, not exist, this circuit. When B is high voltage, so this transistor will work, will operate. So this transistor will be in saturation mode, will be on, and Vout is directly connected to the VCE. Here we don't have resistor, only ground. So Vout equal logic 0 equal VCE equal 0.2 volt equal volt output low. So again, for A equal to 0, this transistor is off. For AB equal to 1, this transistor is on. So the output is directly connected here. So the output equal the voltage VCE here, which is always for BGT 0.2 volt, the output low. The same in inverse. If B is 0 and A is 1, the same. This off, this on, the same, 0.2, logic 0. Also, if both inputs are high, okay, high, two transistors are on, the same, because it's parallel, 0.2 here, parallel with 0.2 will give us same 0.2 volt in parallel, not in sequence, in parallel, okay? In series, we add the voltage. In series, we add the voltage. In parallel, the same voltage. The differ here, the current I will be divided into I1, I2. The I total here equal I1 plus I2 in parallel, but same voltage. So will be the same logic 0, the same 0.2 volt. So this is NOR. NOR is opposite of OR. OR always 1, 0, 0 will be 0, and always 1, OR. NOR is not OR. Opposite of OR will be 1, 0, 0, 0. Okay? Any question? Any question? Clear? Perfect. Perfect. Now, some logic convergence. NOR plus inverter give us OR. NAND plus inverter give us AND. And inverse. OR plus inverter give us NOR. NAND plus inverter give us NAND, or minus inverter or minus inverter. So any logic gates, if you add inverter or remove inverter from it, give you the opposite. Okay, plus or minus. So or plus inverter give us NOR, or minus inverter give us also NOR. So plus inverter or minus inverter, the same output. Okay, to continue now. Now, two input OR gate. Two input OR gate, design one. So we can put the same NOR gate before, the output of the same NOR gate plus NOT inverter here, transistor number 3. So we have now this block is NOR. We do it here, the same here. This is NOR. Okay, this is NOR. So we put it here NOR. The output put a resistor, because of course resistor and inverter here, not give us OR. So this method give us first method or first circuit to create OR. So this is OR. The output of the NOR is 1 0 0 0, as we said before. Now we put inverter here. The inverter will work if output is high, this transistor will be on, then the output will be 0.2 volt, because VCE here. Else when the output, VO output here 0, this transistor will be off, always off, then V output equal 5 volt. Okay, so we'll get this, give us OR 0 1 1 1. It's OR. We create this OR contains 3 transistors and 5 resistors. Okay, the area is 3 transistors and 5 resistors. This is method number 1. Using NOR plus inverter give us OR. This is method number 1. Do you have any question here? It's clear? Any question? Good. Now another method. As you can see here, we put these 2 transistors grounded. All the transistors are grounded. Okay. Now the other method is inverse. We put the transistor in parallel at the VCC. No resistor above, but we put at emitter 1 resistor common and grounded. So we put the 2 transistors parallel at VCC side, not on ground side. Okay, on VCC side, this is OR in another method, method 2. So this is OR. We will trace them. For A and B 0 0, these 2 transistors are off. So the output directly connected to the ground. So right now 0 equals 0 volt. The output low. Okay. One of them is high. A or B is high, or both of us high. One of them, because it's parallel, they are parallel. One of them are operated. So we have here VCE. VCE 5 volt. The output here from the emitter. Now the output from the emitter, not from the collector. The output here. So the output will be equal 5 volt minus VCE 0.2 equal 4.8 volt. So one of them is working, one of them is high, 0 1 1 0 or 1 1. So one of them is on, other is off, or both is on. Give us logic 1. Logic 1 here means 5 volt minus 0.2 volt equal output 4.8 volt. Voltage output high. What is the difference between this method, this circuit, this OR, and another OR? This OR contains only 2 transistors, 3 resistors, and the output low 0 volt and output high 4.8 volt. Whereas Here, the logic 0 is 0.2 volt, not 0, and logic 1 is 5 volt, and bigger, 3 transistor, 5 resistor. So this OR is bigger than another OR, this OR, okay? Any question? Any question? Clear?
Yes, doctor, yes.
Perfect. Now, 2 input NAND gate. So in NOR, we put 2 transistors in parallel. In NAND, we put 2 transistors in series. So we have 2 transistors in series with the ground, not in parallel. In parallel becomes NOR. Put it in series, becomes NAND. So what is the output of NAND? Is opposite of AND. AND will give us 0, 0, 0, 1. NAND will give us the inverse, 1, 1, 1, 0. So we trace this circuit. So we put it to the ground, 2 in series, 2 transistors in series, VCC, and the output remain from the collector. The output from the collector. Now, for 0, 0, 0, 0, these 2 transistors are off. So the output will be directly connected to VCC. 5 volt, the output high. One of them 0, 0, 1 or 1, 0. One is on, other is off. So this will be off. Because in series, we want to be grounded. We want to be at the same time, this transistor is on and this transistor is on to connect it to the ground. Yes? Else, this line is open circuit. To connect it to the ground, it must be both transistors will operate, both together at the same time. So we have it on 1, 1 only. On 1, 1, both transistors are on. So the out is connected to the 2 series, 2 cascading transistor to the ground. So the output equal the summation of the 2 VCE. VCE1 plus VCE2. 0.2 plus 0.2 give us logic 0, 0.4 volt, which is volt output low. So here in NAND, always 1 except of 1, 1 would give us 0. NAND, always 1. The output is false or 0 only when the both inputs are 1. Okay? But here, the output low is 0.4 volt. High voltage here. High voltage. 0.4 volt is error. Give us error. Whereas output high is totally 5 volt. It's correct. It's fine. Okay? Any question? Any question? Okay, this is number 1. Now, I want to construct an AND gate. AND gate, we can put this NAND with inverter. So NAND plus inverter give us AND. Okay, NAND plus inverter give us AND. So this is the first output, the same of here, 1, 1, 1, 0. When we put inverter here, on, off, will give us zeros, 1. Here, zeros is 0.2 volt and 1, 5 volt. This is AND gate. So this is AND gate. This contains 3 transistor, 5 resistors. This is AND gate number 1. Now, AND gate number 2, we put it in series at the top to the VCC part, not to the ground part, and put the resistor to the ground part. So we inverse the image. Okay, here we have 2 transistors series to the ground, and we put resistor at VCC. So we switch out VCC by ground. We switch, okay, to give it AND. So this NAND, if we switch ground by VCC and VCC by ground, becomes AND. Okay, so we will define 0, 0. These two transistors are off. V out will be totally 0. One of them is 0. Also, these two two transistors in series will not work unless both are on. So at 1, at high voltage at 1, these two transistors are on, then this 5 volt will continue the path to the ground. Okay, so we got current right now. So on will give us high. Logic 1 here is 4.6 volt. Why? 5 volt minus 0.2 minus 0.2 give us the output 4.6 volt. It's bad. It's bad for the output. Bad. Okay, bad high. Here we have 2 transistors, 3 resistors. Any question?
بس دكتور why is it bad؟
الباك انه 4.6 فولت. We don't have 5 فولت. اوكي؟ نحن بهمنا الاوتبوت يكون اللي بدنا اياه هون 0 يطلع 0 وال1 يطلع 5 فولت. اوكي؟ ما عم بيطلع معنا 5 بهالطريقه، ما بيطلع 5. بالطريقه اللي قبلها طلع 5 والزيرو طلع 0.2. يعني هالطريقه كاوتبوت احسن، بس اكبر 3 ترانزستور. يعني عملنا 3 ترانزستور مع 5 ريزستور بهالطريقه الان، حطينا ناند مع انفرتر، اعطتنا ريزلت افضل. ال1 5 فولت هذا اللي بدنا اياه، والزيرو 0.2 مقبول، بس على حساب الكوست هو الاريا 3 ترانزستور 5 ريزستور. بينما بالان 2 اصغر كسيركت اصغر 2 ترانزستور 3 ريزستور less area but the output 4.6 فولت، خسرنا 0.4 فولت. اوكي، يعني اذا هذا الاوتبوت فات على اند ثاني والاوتبوت فات على اند ثاني واند ثاني وثالثه ورابعه، ال1 بطل 1 بصير 3 فولت و2 فولت، صار انترميديت، صرنا فتنا بنويز، فتنا بمشكله. اوكي، نحن بنفضل الاوتبوت هي توتال زيرو، حتى اذا عملنا كاسكيدنج اند، حطينا اند مع اند مع اند مع اند مع اند، ضلوا 0 0 0 0 وال1 يبقى 5 فولت 5 فولت 5 فولت 5 فولت. هيدا اللي بدنا اياه، اللي بدنا نوصل له. بس بالبي جي تي ار تي ال ما حنوصل له، ما راح نوصل له. بغير نوع حنوصل له، بهذا النوع البي جي تي ار تي ال ما راح نوصل له. ما عندنا 100% زيرو وما عندنا 100% 1. على طول وحده منهم ظابطه والثانيه ما ظابطه. هون الزيرو ظابط، الزيرو 0 فولت، اوكي فاين كوريكت، but ال1 is 4.6 فولت. if I put 2 NAND هون مع كمان NAND هون and هون، الاوتبوت 1 مع اوتبوت 2، ال 4.6 حتصير 4.1 4.2 وال 4.2 حتصير على طول عم ننقص 0.4. فاذا عملنا 4 ستيب او 5 ستيب 5 ستيبس، ال1 حتصير 3 شيء. فهذا بطل لوجيك هاي، صار ميديوم، فبيعطينا مشاكل باوبريشن لابلكيشن معين. اوكي، فبيعطينا مشاكل. فالبي جي تي للاسف الافضل هيدي، الافضل هيدي. لو زدنا سيركت بس الاوتبوت بعده افضل. اوكي
دكتور، ايال مينيموم في اوت لازم تكون، يعني قد ايه لازم تكون مقبوله؟ يعني 4 بتكون مقبوله ولا لا؟
لا اكيد لا. 0 فولت هو المقبول، هذا بيرفكت. بس
فهيدي مش مفضل تستخدم.
ليه؟ لانه خسرت 0.4 فولت باول كاسكيد، باول جيت. حط جيت ثاني حدا صارت 4.2، حط جيت ثالثه صارت 3.8، عم تنزل بسرعه. فهيدي مشكله. هون مقبوله 0.2، اوكي حط جيت ثاني صارت 0.4.
بس هي بتاخذ اكثر سبيس،
بتاخذ اكثر سبيس، بس الريزلت افضل، بس مش احسن. افضل من هديك بس مش هي البست، مش هي الاوبتيمال. اوكي، فبي جي تي ما بيعطينا الاوبتيمال سوليوشن. خلص الشابتر. اوكي، خلص الشابتر. نفهم بشابتر 3 يلي بي جي تي، البي جي تي ما بيستعمل للديجيتال الكترونكس. افهموها. الريزلت سامري اوف ذيس شابتر that BGT, RTL BGT, sorry, RTL BGT, it's not recommended to be used in digital electronics, but can be used in analog circuit because they have active layer, big active layer. We have here big active layer. Okay, بالactive mode or linear mode, which is amplifier mode, which are not for digital electronics. This part is for analog circuit, for communication engineer and electronics engineers, not for computer engineers. Computer engineers, we are focusing on off, on, not on the middle. So BGT transistor, RTL BGT transistor is recommended for analog circuit, not digital circuit. Okay. So conclusion of chapter 3 about RTL BGT transistor, will not use it in our digital electronic circuit. It's not optimal solution. It will give us errors in the output. Okay, it can work, but give us error in the output. So in chapter 4, we'll see another type which is better than RTL BGT. Okay, واضح? Clear?
Clear, doctor, clear.
So as a summary, I will repeat. As a summary, at the end of this, okay, as a summary of chapter 3, RTL BGT, RTL BGT transistor recommended to be used in analog circuit for electronic engineer and for communication engineer, not for computer engineer, because we are computer engineer. We want to use it in digital electronics. So RTL BGT transistor are not recommended to be used in digital electronics. Okay, because the output is not optimal output. Always we lose in VCE. Always we have 0.2 volt losing it. Okay, this is the summary of chapter 3. And on next lecture on Friday, we'll talk about chapter 4, another kind of transistor, which is better than RTL. Okay, it's better than RTL. We call it, we'll take it on Friday in the morning. Okay, any question? Any question?
No, doctor, thank you.
Good.